we have indefinite integral, and what we have here? In denominator, we have constant number. In denominator, we cannot have zeros, so of course a must be different than 0. Next, what we can do? We can do substitution. I will put u equals x over a. A is constant, so we can rewrite this that u is equal 1 over a times x. Now, because we substitute x over a by u, we have to find du. So we'll find derivative of both sides with respect to x. Du to dx is equal 1 over 8. Derivative of 1 over a times x is 1 over a, because a is constant. So now we need to find du. We have dx in the numerator, so we will multiply both sides by dx. Dx and dx we can reduce, and we have that du is equal 1 over a dx. Now let's look at our function. We substitute x over a by u. So now we have to find dx only, because x over a we will write u, and here we will have negative u. We need to substitute dx. We found that du is equal 1 over a dx. So to find how much equals dx, we will multiply both sides by a. A and a we can reduce, and we have dx is equal a du. A is constant number. So now we can rewrite our indefinite integral to form. It will be e to power u minus e to power negative u, everything square, and we have now a du. When we have multiplication, we can take this constant number before indefinite integral, so we have a times indefinite integral of e to power u minus e to power negative u square times du. So this is equal. Now we will use formula that a minus b square is equal a square minus 2ab plus b square. In our example, a is equal e to power u, b is equal e to power negative u. So we will have to copy a, and we have indefinite integral of e to power 2u minus 2 times e to power u times e to power negative u plus e to power negative 2u. Of course, we have indefinite integral with respect to u. So this is equal, we have a times indefinite integral of e to power 2u. Because we have indefinite integral of difference and sum, we can rewrite to difference and sum of indefinite integrals. So let me put this in brackets. We will have indefinite integral of e to power 2u with respect to u minus indefinite integral of 2, and we have the same base here, so we have to add exponents. U plus negative u is 0, so e to power 0 is 1. we don't have to write, and we have with respect to u integral plus indefinite integral of e to power negative 2u with respect to u. Close the brackets. So this is equal. Now I will solve first integral. So let me write this here. We have indefinite integral of e to power 2u with respect to u. We will do substitution again. Let me put this here. Let t will be equal to u. So now we have to find the derivative of both sides with respect to u. dt to du is equal to, because we substitute 2u by t, so we need to find dt. So I will multiply both sides by du. Du and du we can reduce, and we have that dt is equal to u, to du. We have only in our indefinite integral du, we don't have 2. So I will divide both sides by 2, and we can reduce 2 and 2. We have du is equal 1/2 dt. So we will solve this integral first. This is equal. We will have indefinite integral e to power t, and du is 1/2 dt. So this is equal 1/2 we can put before integral. So we have indefinite integral of e to power t with respect to t. This is equal 1/2 et, of course, plus constant c. And we know that t is equal to u. So we can substitute t by 2u. So we have 1/2 e to power 2u plus constant c. We solved this first integral. Next we have, let me put this, it will be first, second interval and third integral. This was first integral, so I will put c1 here. Next we will solve the second interval. So we will have indefinite integral of 2 with respect to u. This is equal. We can take constant before integral, so we have 2 times indefinite integral of du. So this is equal u. So we have 2u, of course, plus constant second interval, so I put c2. We have second interval. Now we have to solve third integral. So let me put this in circle. We have indefinite integral of e to power negative 2u with respect to u. So we have to do substitution. Let z will be equal negative 2u. So now we have to find derivative of both sides with respect to u. So dz to du is equal negative 2. We will multiply both sides by du because we do z substitution, so we have to find dz. Du and du we can reduce, and we have that dz is equal negative 2 du. We have only du in our expression, so I will divide both sides by negative 2. So negative 2 and negative 2 we can reduce, and we have du is equal negative 1/2 dz. So we can now solve our third integral. So we have indefinite integral of e to power z now, because negative 2u is equal z. And for du we have to put negative, I will put this in parentheses, 1/2 dz. So this is equal negative 1/2 we can take before indefinite integral because this is constant, and we have indefinite integral of e to power z with respect to z. We know that indefinite integral of exponential function e to power z with respect to z is e to power z. So first we have to copy negative 1/2 and we have e to power z, and because we have indefinite integral we have to add constant. So because this is third integral I will put c3. So now we have to come back to our substitution. Z is negative 2u, so this is equal negative 1/2 e to power negative 2u plus c3. So we've solved our three integrals which we have in brackets. So we can replace now this whole expression. We have to copy a, and in brackets we will have first integral is equal 1/2 e to power 2u plus c1. Next we have to put sign negative, and the second interval is equal 2u plus c1, so it will be minus, plus c2, so it will be minus c2. And next, third integral we have equal negative, so I will put this in parentheses. We have negative 1/2 e to power negative 2u plus c3. Close the brackets. So this is equal. First we have to copy a, and in brackets first I will put expression with u. So it will be 1/2 e to power 2u minus 2u. Positive and negative give us negative 1/2 e to power negative 2u. And we have constant c1, c2, c3, so we can combine them together and will be constant c. Now we have to come back to our substitution. First substitution at the beginning, u is equal x over a. So we have to copy a, and in brackets we will have 1/2 e to power 2 times x over a minus 2 times x over a minus 1/2 e to power negative 2 times x over a, plus of course constant c, and we can close the bracket. This is equal. Now we can factorize 1/2, and we can put outside the constant because a is constant and c is constant. So a times c, it still will be constant. So I can put after brackets. So we have a over 2, and in brackets we will have e to power 2x over a minus, because I have only 2 and I factorize 1/2, so I have to put 4 times x over a minus, we have e to power negative 2x over a, and like I said, I will put the constant after brackets, so I can put plus constant k. So this is equal, let me rewrite this one more time, a over 2, and in brackets I will have e to power 2x over a minus 4x over a and minus e to power 2x over a plus constant number. This is my solution.